So let's just move on further and talk about some of the applications of the Heron's formula. So under the application of the Heron's formula, we will find out that how we can find the area of a quadrilateral. So let us suppose we have this type of a quadrilateral and we just wanted to find out the area for this quadrilateral. So as we can see over here, let us suppose if I'm drawing a diagonal of this particular quadrilateral in such a manner, then it will divide the whole quadrilateral into two sections, means if in this triangle as well as in this triangle. So further move on, let us suppose if I am taking these two triangles again in the separate formation as this, and let us suppose if I am taking this. So as we can see over here, this particular quadrilateral is divided into the two triangles, that is into the blue one and into an orange one. So if I am able to find out the area of this blue triangle and if the area of this orange triangle, then the sum of these two triangles is nothing but is equal to the sum of that particular quadrilateral. So this is all about finding out the area of a quadrilateral using the Heron's formula, in which we will separate a particular quadrilateral into two triangles, and then after finding the area of each, we will add the areas and it will give us the area of the whole total quadrilateral. So let's just move on further and see a question which is related with the application of the Heron's formula. So the question number 1 says, the students of a school staged a rally for cleanliness campaign. They walked through the lanes in two groups. One group walked through AC, CD, and DA. So as you can see, we have this particular figure which is related with this, and it says one group is actually walking through AC and CD and DA, and the other group was walking through, and the other group was, this is the first group that was walking through AC, CD and DA, and the other group was walking through AB, BC and AC. So this is an additional information related to this particular question, that one group was walking through AD, DC, AC, and the other group was walking through AB, BC and AC. Further it says, then they cleaned the area enclosed within the lanes. So these were the two lanes, that is AB, BC and AC, and the other one was AD, DC and AC. So it says, then they cleaned the area enclosed within the lanes. If AB is 9 meter, as it is given, AB is 9 meter, BC is 40 meter, CD is nothing but 15 meter, further DA is 28 meter, angle B is 90 degree. Which group cleaned more area and by how much? So it says, find the total area cleaned by the students neglecting the width of the lane. So we have to neglect the width of the lane and we just have to find out the total area which is cleaned by the students. So let us suppose if I am taking this figure further again. So let us suppose this is my figure, and according to the question, the first information given to us is that the group 1 was cleaning the lane by walking on AC, CD and DA. So this is an additional information which wasn't given in the question, which is not present in the question, but I'm giving you here the additional information related to that question. So group 2 was actually walking through the lane A, B, B, C and CA or AC. So the group 1 was walking through these and the group 2 was walking through these. So the question actually asked us find the area cleaned by them. So we just have to calculate the whole area which is cleaned by them. So as you can see over here, for this particular quadrilateral, we have the two triangles as ABC and further we have the triangle ADC. So first of all, we can able to find out the area of ABC because this is nothing but a right angle triangle, and the area of the right angle triangle is quite an easy task for us to find. So let us suppose if we are talking about in a triangle ABC, it is a right angle triangle. So the area of the triangle The area of the triangle is nothing but of the form half into base into height. This would be half into base. Base is nothing but 40 and height is nothing but 9. So this would be nothing but 2 into 2 is 40. This would be nothing but 180 meter square. This is 180 meter square, and this is nothing but the area of the triangle for the very second group. So for the second group, the area which is cleaned by them is nothing but total 180 meter square for the second group. Now let's just talk about the first one. So for the first one, as we can see, for the first one, we have the triangle for the group. For the group 1, we have the triangle ADC. Obviously, it is not a right angle triangle, so using the Heron's formula, we have to calculate the area. But we do know about only two sides. We do not know the third side. So we can able to find out the third side because it is nothing but the hypotenuse of the triangle ABC. So using the Pythagoras theorem, we can able to calculate the AC side. So let's just calculate AC using the Pythagoras theorem. So we say by Pythagoras theorem, in triangle ABC, AC square is equal to AB square plus BC square. So AC square is nothing but is equal to AB square. What is AB? AB is nothing but 9 square. BC is nothing but 40 square. So this would be AC square is equal to 81 plus 1600. So AC square is equal to 1681. So AC is nothing but a square root of 1681, and we do know about the square root of 1681. It is nothing but a square root of 41. So this is nothing but 41 meter. So hence we have calculated the hypotenuse as nothing but 41 meter. So let us suppose if I am writing it over here that this is nothing but 41 meters. So if the third side is now given to us, so we can calculate the area of this particular triangle using the Heron's formula. So let us suppose if I am taking the value ABC. Let us suppose if I am taking by Heron's formula, let us suppose if I am taking A as nothing but a 41, if I am taking B as a 15, and I am taking C as 28. Let us suppose if I am taking A 41, B 15, C 28. Let's just find out the semi-perimeter first. So the semi-perimeter is A plus B plus C divided by 2. This would be 41 plus 15 plus 28 divided by 2. Further, this would be nothing but of the form, this is nothing but 4 plus 1 is 5, and this is 6. 5 plus 1 is 6 plus 28 divided by 2. Further, this would be nothing but 8 and 6. This is 4. Further, we have 5, 6, 7 and 8. 84 by 2, and this is nothing but 42. Hence, the semi-perimeter is coming out to be 42 meters. Semi-perimeter is 42 meters. Now let's just calculate the area using the Heron's formula. So the area of the triangle ADC is equal to square root of S minus A, S minus B, S minus C. Plug in all the values over here. This is square root of S. What is the value of S? 42. 42 minus A. A is nothing but 41. We have taken A as 41. 42 minus 15. Further, we have 42 minus of 28. So let's just calculate the value. So this is nothing but 42. Further, we have this as 1. This would be nothing but 7. And this would be 3. 3 minus 1 is nothing but 2. Further, we have the value as nothing but 12 and 8. So this is nothing but 4. We have 3 left. 3 minus 2 is nothing but 1. So this is 14. Now it means we have the value as nothing but 42, 27, and we have 14. So let us suppose if I am starting with this one, we have 42. We can write it as 7 into 6 is 42. Further, we have 27. So we can write it as 9 into 3. Further, we have 14. We can write it as 7 into 2. So let's just take the elements or the numbers common out of the square root. So first of all, we have a group of 7 and 7, so we can take the 7 common out of it, and further we have 3 into 2 is 6. We have this is nothing but again 6, so we can take a 6 common out of it. As you can see, we have this as 3 into 2, this is nothing but 6, this is nothing but 6, so we can again take the 6 common out of it. So let's just look out for those elements which are not common under here. So if we'll take the 9 out of the square root, this would be nothing but 3. So hence at the end we have the values as nothing but 6 into 7 is 42, 42 into 3 is nothing but 126. At the end, this is nothing but meter square, this is meter square. So hence the group 1 or the area which is claimed by the group 1 is nothing but of the form or area of ADC is nothing but 126 meters square. So first of all, if I'll compare both of these areas, this was the area for the group 2, this was the area for the group 1. So as you can see, group 2 has cleaned the more area than the group 1. As you can see over here, if I'll compare both of these areas, so I can see over here that the group 2 definitely have cleaned the more area than the group number 1, and we can also find the difference in between these two by subtracting them. 180 minus of 126, so we can calculate the comparison in between the areas or the cleaned areas which was cleaned by the two groups, that is the group 1 and group 2. So obviously the group 2 has cleaned more area rather than the group 1, because the group 1 area is 126 meters square and the group 2 area is 180 meters square. And we can also find the difference by taking a difference of 180 and minus 126. Now let's just talk about the total area cleaned by them. So the total area cleaned by them is nothing but is equal to the area of the triangle ABC which was cleaned by the group 2 and the area of the triangle ADC which was cleaned by the group 1. So this is nothing but 180 plus 126 meters square. So hence at the end we are getting the answer as 306. As you can see, 6 plus 0 is 6, 8 and 2 is 10. So this is 1, 1 and 1 means 306 meters square. So the answer for the total area cleaned by the two groups is nothing but 306 meters square. This is 306 meters square, and this is nothing but our answer. Furthermore, we can calculate the difference in between the two areas by taking the difference of 180 and 126. So this is all about the question which is related with the applications of the Heron's formula. I hope all the steps related to this particular question is all clear to you.